So here we've been told that the particle has mass 2 kilograms, there's a constant force acting and therefore a constant acceleration, so we can use SUVAT in our question here. So part A is asking us to find the angle in degrees between the direction of motion, so we're going to use the velocity vector at time is equal to 3. Okay, and we want the angle between the direction of motion and the j vector. So we'll just do a quick sketch to show what's happening here. So j vector is parallel to the y-axis, with the velocity vector is 1 to the right and -2 down. So I'm interested in the whole of this angle here. So first of all, I'll work out theta, this angle. So opposite over adjacent equals tan theta, and gives me an angle of 63. This angle here is now going to be the required angle of 153.4. Now I could give that angle to one decimal place like I have, or I could give it to 3 significant figures, 153. Okay, part B is asking us to find the acceleration of p. So as we said before, we can use our SUVAT equations. So I'm interested in, this is my initial velocity, my final velocity. I don't know the acceleration, that's what I'm trying to find out, and the time period is 3. I can use v equals u plus at, just rearrange that. It gives for the acceleration is v minus u over 3. So let's first of all work out the vector v minus u. So I've got 1 minus 2 minus 5, 7, and that gives me 6 minus 9. I can then find the acceleration because it's a scalar product of 1/3 of this. It gives me 2 minus 3, so in I and j form it gives me 2I minus 3j meters per second squared. So part C, I'm asked to find the magnitude of F, so I can use F equals ma. Now I know the mass is 2 kilograms, I already know the acceleration, so just substitute into the equation, and that gives me 4I minus 6j. Now I'm being asked to find the magnitude, so I'm going to use Pythagoras, 4 squared plus minus 6 squared, and the square root of that, and it gives me 3 significant figures, 7.21 newtons. So part D is asking me to find, in terms of t, the velocity of p. So this generally is going to be a general formula for the velocity of this particular particle. So I'm going to use v equals u plus at. I've already got my acceleration vector, and I have my initial velocity. Let's substitute into the formula, expand out, and collect like terms. So here I can now factorize to give a general equation in terms of t for the vector velocity. Part E is asking me to find the time at which p is moving parallel to the vector I plus j. Now if I look at the vector I plus j, I can see that it has a gradient of 1, so I'm looking for the time when my vector velocity also has a gradient of 1. So I can use the equation for the vector velocity. In the x direction it's minus 5 plus 2t, in the vertical direction it's 7 minus 3t, so the gradient of that, the rise over the run, must be equal to 1. So I've got an equation now with one unknown, cross multiply gives me this, add and subtract, which then gives me a time of 2.4 seconds.